Okay. So I heard that the first thing we look for is a GCF, which stands for greatest common factor. So really the skill I'm looking at this week is not that can you factor. I know if you're sitting in this room, you can do that because you made it to second semester, right? Okay, I wouldn't have let you keep going had you not been able to factor. All right, I would have taken you and slowed you down. Okay. The skill I want you to focus on is I want you to be able to look at the problem and identify what the type of factoring is. Today, we're going to go through all of them just to review the factoring, but that's the idea is I want you to be able to look at the problem and go, I know I need to do a GCF. I know I need to do difference of squares. I know I need to do magic X. Okay. All right. So we know that this one is GCF, which stands for greatest common factor. Yes, write it down. Okay. Write it one time. Okay. One time. I'm only going to write it one time. I'm already needing another vacation. Okay. Because Daniel's giving me a hard time on the first day. All right. So looking at that problem right there. Okay. So we're looking at number one. What is the greatest common factor? Okay. I heard lots of things. Okay. And those of you that are new, it does not matter if you give me the right answer or the wrong answer. I prefer you just give me an answer. Okay. So that you participate. All right. So I heard 3 and an X. So you want to make sure the number, factoring is just division. Okay. Remember, all it is division. That's the operation that we're doing is we're dividing it up. Okay. So I'm going to pull out the number that divides all of them. And then if I see an X in all of them, I want to pull the smallest exponent. So my smallest exponent was an X. All right, I'm going to write this a little bit differently. Pay attention, okay? Because I'm going to show a step that I didn't show last semester, but I showed a few of you at the end, and it seemed to help a few of you. Okay, so if this helps you, great. If not, you can just keep doing it the way we were doing it. Really, what I'm doing is I'm dividing this by 3x. Okay, so when I divide that, what do I end up with? Good. Remember when we subtract our exponents, right? 4 minus 1 because that's a division sign. Okay. I am now dividing this by 3x. So what do I get when I divide it by 3x? Negative 1x. Do I need to write the 1? No. Okay, I'm going to divide this one by 3x. And what do I get? 2. Good. Remember, when we are factoring, we always look to see if it can be factored more. Okay, that's called factoring completely. In this case, that's not a squared. It's not a quadratic, right? So it's not going to be a magic X problem. That would have to be squared there. So we're probably done at this point. Make sure you have the 3x in front. We didn't divide it out and it go away. We factored it out. Okay, so it has to be written there. Okay. All right. I want you all to try number 2. Okay, I made it easier than number 1. Identify the type of factoring and write it out. Put the phones away. Pay attention. We get this done. Now factor. Manuel, you need to be at a table that actually has a seat. So come sit over here, please. Let me do this. Like X plus. No, it's just X plus times X plus. Exactly. Okay, let's take a look. Okay, shh. I heard a couple of different things going on, and one of them was good, right? And one was wrong, but it's okay to have the wrong one because I want to be able to point it out. What type of factoring? Greatest common factor. What was the other thing some people were saying? What did I hear? Okay, let's talk about why it's not difference of squares. Okay, so this is not right. Let's talk about why. Okay, because that's important that you understand that. It is GCF. Okay, It makes it look like difference of squares because how many terms do I have? 2. Is this a square? Is this a square? Is this a square? 16 a square? Yeah. Is x a square? No. Okay, so that just killed difference of squares. Is it a difference? No. So that just killed difference of squares. For those of you that are new in the room, if you look at both sides, there's a sign that says number, square, cube. Remember square numbers? The square numbers are going to be the ones that are in the middle. Okay? All right. So it's not difference of squares. It's greatest common factor. All right? So what was the greatest common factor you pulled out? 4x. Good. What's left behind? So when we divided it out, what'd you get? Everybody good with x plus 4? Notice, I didn't do the divide by 4x part this time. It's okay if you do that. You don't have to. Okay? All right. Let's take a look at number 3. Okay? So, the very first thing you should be asking yourself is there a greatest common factor? So look at those terms. Is there a greatest common factor? I got both yeses and nos. What do we think? No. Is there anything that divides both 49 and 16? No, so that's not greatest common factor. How many terms do I have? 2 terms, okay? When I have 2 terms, I then look for squares. Is the 49 a square? Is the x a square? Is the 16 a square? Look at this squares list. Is 16 a square? Okay, is there a minus sign? So this has to be difference of squares. Remember, we want to know what the different names are. That's the goal this week, is to get the different names down. Okay. All right. Difference of squares factoring is really the easiest one. At least I think it is. Okay. We know it has to factor into a binomial times a binomial. Okay. We're going to take the square root of the first one. So what's the square root of 49? What's the square root of x squared? So we write 7x up front. Okay. All right. What's the square root of 16? So I'm going to write that in the back. Then we make one a what? One a positive, one a negative. Easy peasy, right? That's all I got to do. Square root, plus minus. Okay? All right. I want you to try number 4. So everybody's going to try number 4 right now. Just leave it. That's it. You're done. Okay? We're not trying to solve or anything. We're just factoring today. Okay? Do not go for it.
I did.
Did you do number 4 already?
Yeah.
Oh, okay. You're ahead.
The difference of squares.
Okay, I want you to check it with somebody at your table. So have a conversation and check and make sure you both got the same answer. All right, let's talk about it together, okay? Is there a greatest common factor? Notice I've asked myself that question every single problem, okay? How many terms are there? 2 terms, okay? We have to decide if they're squares. So is 4 a square? Is x squared a square? Is 25 a square? Is it a minus sign? Yeah, so what kind of factoring? Difference of squares. I'm being lazy now. Okay, so that means a binomial times a binomial. What is the square root of 4x squared? What'd you get? Good. What's the square root of 25? 5. Make 1a. Yeah, it doesn't matter if I put the plus first or the minus first. I can write it like this. 2x minus 5 times 2x plus 5. It does not matter. That's the same answer. Okay, I have to give you credit for that. Okay? All right. Let's keep going. Okay, we're going to keep trying this. So remember, we're running through all the different types we know right now. So I'm going to go through the line of questioning that we would go through every time. Okay? Even though I know you all know what this one is. Okay? Now, if you were in another classroom, all right, it is possible you learned a different terminology for this. We're going to catch you up with the Ballard lingo. Okay? So, is there a greatest common factor? No. Okay, so I'm going down the list. How many terms does it have? 3. You count them. 1, 2, 3, right? Okay, if there's 3 terms, what do we need to try?
I found this on the web.
Thank you, Siri. Magic X is what we call it. Okay. Now, you might know how to do this and maybe don't know that terminology. Okay. So I'm going to teach it like I'm teaching it for the first time for our new people. Okay, everybody? So I'm going to draw an X. It's literally a tool to help us factor. Okay. What I do is I take and I multiply the first coefficient, which is a 1, times the third coefficient, which is a 10, and I put that up top. Okay. Then whatever is in the middle, that goes in the bottom. Okay. Then we need 2 numbers that multiply to the top and add to the bottom. So what do you guys think? 2 and 5. So let's check that. 2 times 5 is 10. 2 plus 5 is 7. Everybody good? Okay. Now, because my leading coefficient, that's what I call this number in front of the x squared.
I didn't get that. Could you try again?
Siri is having trouble today. All right. The leading coefficient is 1. We just read it right off the x. So we go x plus 2 times x plus 5. Okay? All right. I want you guys to try number 6. Identify the type of factoring, and then write out and then try your magic X. Okay? Everybody try it. You're doing number 6 right now. Okay, I want you to check it with somebody at your table, please. Okay, let's talk about it together. Make sure we've all got the correct answer. So, is there a greatest common factor? No. How many terms? 3. So what type of factoring? Magic X. So that's what we call it in here. Again, it might have another name in another classroom. Okay. All right. So what goes in the top of my Magic X? -8. So the 1 times the -8. Okay. What goes in the bottom? 2. Good. So we needed 2 numbers that multiplied to -8 and added to 2. Everybody okay with that? I heard one person answer. Everybody get -2 and 4. Okay. So we've got x minus 2 times x plus 4. Okay. Ryan, put your phone away. Okay. Let's take a look at number 7. Okay. So look carefully at that problem. We've got 2x squared minus 9x minus 18. Is there a greatest common factor? Your brain kind of wants to trick you though, doesn't it? Because we know 2 goes into 18, we know 9 goes into 18, but it's not a greatest common factor because it doesn't go into all 3, right? So, how many terms are there? 3. When we do 3 terms, what do we have to start with? So I know I'm going to use a magic X. Okay, so let's start there. Okay. I know we do. Be patient. Okay. All right. Remember, I'm going to multiply these two things together. Okay. That's what I was doing all along. Okay. So what is 2 times negative 18? Good. And if you need a calculator, that's fine. You can pull out the calculator. It's all right. All right. And then what's going to go in the bottom? Negative 9. Good. Okay. So I need two numbers that multiply to negative 36 and add to negative 9. Negative 12, positive 3? Everybody good with that? Okay. You're listening. Okay. So we know that it's a magic X. So I'm going to write something down. Do not copy it, but please watch, because you need to understand the why. Okay, especially if you weren't in here last semester. Okay, so the magic X, just like we did on the last problem. If I just write X minus 12 times X plus 3, if I went back to FOIL that out to check it to see if I got it right, what's X times X? X squared. Do you see how this and this no longer match? That means I need to do something else. Okay. So if you were in either Artifer or Hanvey last year, they did something with a box. It's going to be similar to what I do right now. Okay. All right. So we need a box. Why do we need the box? Because I have that leading coefficient. Okay. And that's some vocabulary that we need to make sure we are clear on. Okay. So the top left-hand corner, I'm going to color code it a little bit, is the 2x squared. Okay, whatever your first term is. Okay. Bottom right is always going to be the third term. Then we're going to use in the other two places, and it does not matter the order for our now, follow mine. Okay. The two numbers from the magic X. So negative 12x and 3x. Okay. Now you're going to ask yourself, so it's not just magic X. Sorry, I've noticed we didn't. It's the magic X and the box. Sometimes I'll call it the X box method. You got to do the X and the box. And it happens when you have a trinomial with a leading coefficient. Okay. All right. What times what is 2? 2 times 1. Okay. So I'm looking for this. I'm trying to undo the division. So I'm trying to reverse it with some multiplication. Okay. And just this acts like a multiplication table from elementary school. So I know I have whatever I put here has to divide into 3. So if I put the 2 here, does it divide in nicely? It always divides in because we can always get decimals and fractions, right? But we want it to be nice. And it doesn't divide nice, so I'm not going to put my 2 there. I'm going to go over here and put my 2 on the side. Does 2 divide 12? It does nicely. And then I threw the x there. I know my other number has to be 1. The x is the x times x is x squared. Okay? All right. Now we're dividing, right? That's all the factoring is about, is division. How many times does 2x divide negative 12x? And that number pops up here, because if I multiply those two boxes together, I get negative 12x. How many times does 1x divide 3x? 3 times. Here's the beauty of this method. Negative 6 times negative 3 is, and it just checked itself. Okay, so you know you got it right. We may not leave the answer on the box. Mrs. Ballard does not allow that, does she? All right, so 2x plus 3 and x minus 6. Can you multiply it back out? Oh, yeah. You can do this. There you go. I'm sorry, my last lesson was we were reversing the process last period, so that's where my head is. Okay, I want you to try. I did that one kind of slow. Okay, for our people who weren't with me last semester. I want you guys, everybody's trying number 8. I'll kind of leave it up there, so if you need to look at number 7, it's there. Okay, everybody try number 8 right now. I need to know who not to put next to each other.
That's crazy.
I know you are. You're doing fine. You're not the only one in the room.
Grandmother. That's culture. I know everybody's talking.
I'm going to remind you that when I get to see you, Charlie. You're cool with everybody. We have like 5 absent today, so we should fill every seat. That talks to everybody? That doesn't talk to anybody? Oh, your own island? We don't have enough room in here for that. You guys are too big now. Okay, I want you to check in with somebody at your table, please. Quickly. Quick check with somebody at your table. I should hear some talking about factoring and comparing answers. Okay, we're going to talk about it together now so I need everybody to listen. Okay, because I want to make sure, because this one had a little bit of a trick to it that I want to make sure that everybody is aware of. Okay? So, is there a greatest common factor? I've asked that every single time, right? Because we should ask it yourself every single time. How many terms are there? 3. What do I need to do? Magic X. Just Magic X? Why on box? There's a leading coefficient. We need to use the box. Okay, so we already know that going in. Okay? All right, so what do I get in the top part of my Magic X? 15, because I'm multiplying 3 times 5. What goes in the bottom part? Good. Here's the one. This trips people up because they don't remember to look for it. What multiplies to 15 and adds to negative 16? Okay. So don't forget to use the 1 times something. That comes up more than you think it would. Okay. So 1 times the number, it comes up a lot, and we get multiply to negative 15, add to negative 16. All right. You already told me I have a leading coefficient, so I'm using a box. Okay. Top left-hand corner of that box, what's going to go there? 3x squared. Bottom right's going to get 5. You might have written this down differently than me, and that's okay. You guys, we need to be quiet. It's negative 1x and negative 15x. Okay? All right. What times what is 3? There's not a lot of choice. 1 and 3. Will my 3 divide into the 1? So in my case, it will divide into the 15. So I need to put my 3 on the top. Okay? And you may have reversed that, and that's okay. How many times we're dividing? How many times does 1x divide negative 1x? How many times does 3x divide negative 15x? And then you check it. Negative 5 times negative 1 is 5. So 3x minus 1 times x minus 5. Okay? All right. We're going to attempt to squeeze in 2 more. We have plenty of time because the bell doesn't ring for another 8 minutes. Okay? All right. You're listening. Let's go to number 9. Okay? I want everybody to look at number 9 and think about what you would do first. Don't call it out yet. Think about it. All right? So, we have 3x cubed minus 12x squared minus 15x. What do we always look for first? Is there a greatest common factor? Yes. So we know we're starting with GCF. You can write GCF this time. All right, what is my GCF? Everybody on my board? It's 3x. Okay. All right. I am dividing by 3x. If you need to do this, you can. You don't have to. Okay. So when I divide 3x cubed by 3x, what do I get? Do I get 3x squared or x squared? X squared. Good. Okay, so I heard both. All right. When I divide negative 12x squared by 3x, what do I get? Good. When I divide negative 15x by 3x, what do I get? Good. Now, every time I factor a greatest common factor, I need to check if I can go more, right? That's called factoring completely. How many terms do I have in there left? 3. What do I need to check? Okay, so let's check our magic X. It may or may not work, okay? So I need 2 numbers that multiply to negative 5 and add to negative 4. Oh, there it is again, right? 1 and times something. 1 and negative 5. Everybody good? They multiply to negative 5, add to negative 4. Do we have a leading coefficient in this little chunk here? No, so I can just do my binomial times my binomial. You need to drop, good, I heard it, drop the 3x down. So we've got x plus 1 times x minus 5. Okay? All right. This piece, really important that you make sure you drop it, okay, because it's part of the factored form. All right, there's one more left, right? Okay, everybody try number 10. Everybody try 10. Is it okay? All right, let me know if you're not. I don't know, did you do it right? Why weren't you paying attention? Okay, now do the next one. Come on, I could have made it way harder. I did that. Yeah, nice. You can use a calculator if you need to. That's fine. You know I have no problem with that.
I'm on Broadway. Oh, you're done?
Okay, let's check it. Okay. No, we can't. We can't let anybody out the last 10 minutes. Okay. This bell's gonna ring in just 5 minutes. You can wait. Okay. All right. So let's talk about it together. What's the first thing we always look for? Is there a greatest common factor? Okay. There is one. What is it? Ooh, we caught that it was the squared, right? I made the exponent higher this time. All right, so that means we're dividing that out. Remember, you're subtracting your exponents. So when we divided out the 5x squared from the 5x to the fourth, what'd you get? Good. What about with the 35x cubed when you divided it? Good. And then when we divided it, the 60x squared, what'd you get? 12. Okay, I've got a trinomial left. What kind of factoring? Remember, today's goal was to make sure we could identify the different types. Okay? All right, so I'm trying my magic X. 2 numbers that multiply to 12 and add to negative 7. Everybody good? What do I need to make sure I write down? Where's the mistake going to happen? Good. Drop your 5x squared. We get x minus 3 times x minus 4. Okay? All right. I'm not assigning anything for tonight. Tomorrow we're going to jump back in. We were doing rational expressions before break. We're going to jump back into that tomorrow. Okay? You'll be fine. Can you add a fraction? Can you subtract a fraction? We'll figure it out. Okay? If you can factor, that's half the battle. Okay?